In this particular lecture, I am going to talk about mesh quality metrics. So what are the different metrics that can be used to quantify the quality of the mesh that you have generated for performing an FE analysis? Here we are not going to talk about any theory, we are just going to know what are the parameters and what are the values of these parameters which correspond to a good mesh. So the first one is the aspect ratio. So here the aspect ratio will range anywhere from 1 to 20 and to infinity, and if you want to have a good mesh you need to have an aspect ratio very much nearer to 1, and if it is anywhere from 1 to 3 it is somewhat okay, but if it is crosses 3 it is not okay. Then coming to the next one, it is known as the Jacobian ratio, and this Jacobian ratio also varies from 1 which is perfect to infinity which is bad. So this particular value can range anywhere from 1 to 5 to be said as a good mesh, but once it crosses the 5 value the mesh quality is going to get deteriorated. Then coming to the third parameter, it is the warping ratio. So for 2D elements it is going to range from 0 to infinity. Likewise for 3D elements also it is going to range from 0 to infinity. Coming to 2D elements, if you want perfect mesh, this warping ratio should be near equal to 0. If it is ranging from anywhere from 0.01 then the mesh is good, but if it is crossing 0.1 the quality of the mesh is going to deteriorate for 2D elements. Then coming to 3D elements, if the value ranges anywhere from 0 to 0.2 you will get a good mesh, and once it crosses 0.2 to 0.4 it is okay, and if it is going to cross 0.4 the mesh is not good. Then the next parameter is known as parallel deviation, and this parallel deviation also ranges from 0 to say 170, and if you are going to get a value anywhere nearer to 0 then you can say you have built a good quality mesh. The next parameter is the maximum corner deviation. In this, if we are going to have a 3-sided element, it is going to range anywhere from 60 to 165. Likewise, if we are going to have a 4-sided element, we are going to have anywhere from 90 to 180. In order to get meshing good, you need to aim for this value which is very much nearer to 60 for a 3-sided element. And then coming to the 4-sided element, the value of maximum corner deviation should be anywhere nearer to the 90 mark in order to achieve good mesh. The next parameter is known as the skewness. So it ranges anywhere from 0 to 1. If you have any value ranging from 0 to 0.6 or 0.5, you are going to have a good mesh. Then if it is crosses 0.5 to 0.7 it is okay, but if it is going to cross 0.7 you are going to get a low quality mesh. The next parameter is known as orthogonal quality. So if you want to have a good mesh, then this particular value of the quantity should be anywhere nearer to the 1 mark rather than nearer to be 0. If you are having an orthogonal quality nearer to 0 then you are going to have a low quality mesh. And these are the different quality metrics that are used to study the quality of the mesh that is generated onto this particular geometry. Then remember, all of these things are based upon the type of geometry you are meshing and type of accuracy you require, and it all depends on a lot of other factors. Now we are going to open Ansys Mechanical, and then we are going to see how we can access all these quality metrics inside meshing module of Ansys Workbench. So see here, I have opened Ansys Mechanical in which we have done the meshing. So once you have done the meshing, you can come to this details view, and in the details view you can select the quality. You can expand the quality group. In this quality group you are going to get all the metrics that are required for testing the quality of the mesh that is generated on the geometry. So for that purpose what I am going to do is, here there is an option called mesh metric. In this I am going to select whatever the type of mesh characteristic or mesh quality test I want to perform. Then coming to aspect ratio, I am going to select aspect ratio. Once you have selected the mesh metric, here in the graph area a bar graph will be visible, and from the bar graph you can see this is the type of elements that were used to mesh this particular geometry. See here, tet means tetrahedron elements were used to mesh this particular 3D objects. And you see here on the x-axis you are going to have the mesh metric. Here the mesh metric is aspect ratio, and on the y-axis you are going to have the number of elements that were created while meshing this particular geometry. Then here my lowest quality of aspect ratio is nearer to 1.20, but from the mesh quality chart we can say that this particular value of aspect ratio should be very much nearer to 1 in order to get a good quality mesh. So see here, it is somewhere around 1.7 or so. We can refine this particular mesh and we can just improve this particular quality. So what I am going to do is I am going to go to this mesh group and I am going to increase the relevance without changing any other settings. So I have increased the relevance to the maximum point, and I am going to right click, say generate mesh. So now once I have refined this particular mesh, see here the particular elemental quality has improved and it has come down from 1.20 to 1.17. And likewise you can select any of this particular mesh metric and find out how the quality of your mesh that was generated. Then coming to the graph here, if I am going to click on any of this particular bar, you can see it is highlighting all the elements that are having this particular characteristic. So if I click on here, it is going to highlight what are the elements that are having an aspect ratio of above 4. Likewise I can also click on here and I am going to see that there are 2 elements which have the quality of aspect ratio of around 22.77. So this is how you can use the quality metrics present inside Ansys Workbench to perform quality analysis on your generated mesh. In the next section you are going to see how to perform structural analysis inside Ansys Workbench. Thank you.